Hi everybody. Today I'm going to be going over the Unit 3 test review for your algebra test. There will be a non-calculator and a calculator section. This first part is the non-calculator. You need to know features of a polynomial function, which are listed below, determining whether a function is a polynomial or not, and sketching a polynomial given the end behavior in zeros. All of that is mentioned in these problems down below. So to start, it just says fill in the following in behavior chart using arrow notation. So if I have a positive leading coefficient with an even degree, first of all, even degrees, we know that the arrows point in the same direction, and odd degrees point in opposite directions. Now, if you need to, I'm a visual person, so I'm going to kind of like sketch an example of these, but if you have a positive leading coefficient, that means that the right part of your graph will point up, and then if you have a negative, the right side will point down. Okay, that's kind of how you start this. So if I have a positive leading coefficient, the right side points up. If I have an even degree, the left side also points up. So as x goes towards negative infinity, so to the left, my y values go up, so it goes to positive infinity. And as my x values go to the right, my y values are pointing up as well, so positive infinity. And that makes sense because even degree, these should be pointing in the same direction. Okay? Let's look at a negative leading coefficient. So the right side points down, and because it's an even degree, it's going to point in the same direction. So as I go to the left, my y values point down, so this goes towards negative infinity. And as my x values go towards positive infinity to the right, my y values are pointing down, so negative infinity. And look, these are in the same direction. All right, positive leading coefficient, right side's up. Odd degree, I'm going to point in the opposite direction. So as x goes towards negative infinity to the left, my y values are pointing down, so y goes to negative infinity. As my x values go towards positive to the right, my y values are pointing up, so they go to positive infinity. Alrighty, a negative leading coefficient and an odd degree, that means I'm going to point in the opposite direction. As my x values go to the left, so negative infinity, my y values point up, so positive. And as x goes towards positive infinity to the right, my y values are pointing down, so negative infinity. Okay, so if you guys can kind of like picture what the graph might look like its end behavior, you can fill in that chart very easily, okay? Make sure you know how to write out this arrow notation, okay? All right, now it says fill in the following table of even and odd functions. Graphically, remember that an even function is symmetric with the y-axis, and an odd function graphically is symmetric with the origin. I like to think of odd functions as all O's, right? Odd, opposite, odd, origin, they all go together. That's a way for you guys to remember. An even function, when you're trying to determine if a function is even or odd algebraically, remember you need to simplify f of negative x. If this simplifies and equals f of x, the original function, then it's an even function. If all the signs change, so like they become the opposite signs, it's odd, okay? So these are when the signs all stay the same. These are if all the signs become opposite. Again, odd, opposite. If there's no symmetry, it's neither. And if some of the signs change and some of them don't, it would be neither as well. All right, so let's do an example down here. It says, use the function x to the fourth minus 2x squared minus 8 to answer the following following questions in graph. So x-intercepts, I want you guys to show your algebraic work here. Notice when you have x to the fourth, that's really just x squared times x squared. Because we have a trinomial here in OGCF, we can go straight into setting up our two sets of parentheses, right? Factors of 8 that add or subtract to get 2 would be 4 and 2. Let's see, my signs, it looks like I need -4 plus 2. This gives negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2, so I'm good there. Remember, you guys can draw your boxes if you need to. Excuse me. Now I'm going to see if I can factor any of this further, right? This is a difference of two squares. I have the minus sign, and I can take the square root. So the square root of x squared is x, and the square root of 4 is 2. And then I have x squared plus 2 equals 0. All right, and now I'm just going to set each of those factors equal to 0 to solve for x. Okay, so x equals negative 2, and I get x squared equals negative 2. Then I got to take the square root. So x equals, remember when you take the square root, you get plus or minus. Square root of a negative is I, and I cannot take the square root of 2. Notice I have 1, 2, 3, 4 solutions because I square root 2 and negative I square root 2, and I have a degree of 4. We learned that later on in the unit, but that's kind of a way that you guys can check yourself to make sure you're on the right track there. All right, the y-intercept here is just the c value. When I plug 0 in for x, I get negative 8, so it's 0, negative 8. My end behavior, I can look at the leading coefficient and the degree of the polynomial. Well, the leading coefficient, remember, you won't have a calculator, so you do need to know how to do this. The leading coefficient is positive, right, because that's a 1. The leading coefficient's 1. So because that's positive, the right side's going to point up, and then the degree is even. We have a degree of 4, so the left side is going to point in the same direction. Okay, so I know it's going to point up on these sides. So I know that as x goes to the left, my y values will go towards infinity, and as my x values go to the right, my y values still go towards infinity. Now it says determine if the function's even, odd, or neither using algebra. So this is when we're going to simplify f of negative x. Okay, so anywhere I see an x in this, I'm going to plug in a negative x. Make sure you guys are using your parentheses when you plug in stuff, right? All right, if I take a negative number, multiply it by itself 4 times, it becomes positive. Negative times a negative is positive, times a negative makes it negative, times another negative makes it positive again. So this becomes x to the 4th. Minus 2, 2 negatives make a positive, so positive x squared minus 8. Notice all the signs are the exact same as what we started with, so this is an even function. It's even because f of negative x equaled f of x. It equaled the original function. If you just say it equaled the original function, that's fine. All right, now it says use the coordinate plane above to graph f of x. Make sure you include a scale on your axes and plot the intercepts accurately. Plot at least one point between each set of zeros. Show your work for these points. So let's start with the x-intercepts. Looks like they're going to fit on the x-axis. So negative 2 and 2. Remember, these are imaginary zeros, so I can't plot. They're not on the x-axis. I have a y-intercept of negative 8. 1, 2, 3, 4, 5, 6, 7. I'm off by 1. I'm going to count by 2s here. 2, 4, 6, 8. Okay. And my x values, I'm counting by 1s. All right. And then make sure to include, okay, so let's plot, okay, so we want to make sure you include a scale on your axes and plot at least one point between each set of zeros. So even though I have this 0 right here, I'm going to plot, or I'm going to solve for what's in between 0 and 2, so I'm going to use 1. So I'm going to find out what x equals when it's 1. So I'm going to do 1 to the 4th minus 2 times 1 squared minus 8. So that gives me 1 minus 2 minus 8, which is, let's see, negative 9, right? Negative 1 minus 8, negative 9. Okay, so that would go, I'm like, okay, yeah. So I have a coordinate point at 1, negative 9. So 1, 2, 4, 6, 8, 9. And guys, because this, remember how we said it's an even function? Because it's even, that means it's symmetric with the y-axis. So whatever on this side will be on this side as well. Right? So I can automatically know that that's going to go there. Now this one's kind of weird because we only have 2 zeros and I have a coordinate point in between them already. So just make sure you at least show me one. But I want to see like as many points as like you can give me. So from here, I can kind of get an idea of what this is going to look like. It's going to like kind of go like this. Okay, and double check on the y-axis, are these the same on both sides? Yes, it is. So that's where the even function comes from. Okay, and look, my graph had a point up and it does, so I'm good. Alrighty, on to the back. Polynomials have the following features, okay? Blank are positive whole numbers. That means that we have to have exponents. Exponents have to be positive whole numbers. And then our coefficients have to be real numbers, okay? So give me an example of a polynomial. That would be something like 2x squared. An example, well, because look, I have my coefficient's a real number and my exponent is positive and whole. An example of a non-polynomial would be like 3 to the x, because my exponent here is a variable and not a positive whole number. So that's kind of just like a little example of that. All right. So you'll be given some polynomials and you have to decide if they are a polynomial function or not. All right, number 5, it says sketch a polynomial that has the following in behavior in zeros. So, as x goes to negative infinity, so as I go to the left, my y values point up, and as x goes to positive infinity, my y values point up as well, because this is positive infinity, okay? And then I have a 0 at 4 and at negative 3. So, these are the only zeros I have. I can't go through the x-axis again. So it looks like if I just connect these dots, I have my polynomial function. Okay, so I'm at 4 and negative 3. You guys don't have to be like exact on your points because all I give you is the zeros. And in behavior, I just want to see if once I give you the zeros, you know that I can't cross through this graph any more than at the 4 and the negative 3. Okay, so you'd have to figure out how to connect those with both arrows pointing up because our y values have to go towards positive infinity. Okay? All right, so that's the non-calculator section.